Okay, for tonight's video, I'm working through some of the problems on the Chapter 8 review. So I have that worksheet out and also possibly a sheet of lined paper and your graphing calculator. So I'm working through problems numbers 1 through 12 and 17. Number 1 says if x equals a times the square root of b divided by cd, which expression is equivalent to log x? All right, in other words, we have to expand this. So we have to take log of a square root of b divided by cd, and we want to expand. Now remember, so we have here a times b to the 1/2, right? The square root is equivalent to the fractional exponent of 1/2 divided by c times d. So remembering our rules for logs, this would expand to log a plus 1/2 log b minus parentheses log c plus log d. All right, and if that is not one of our 4 options, then distribute this negative here over parentheses. So log a plus 1/2 log b minus log c minus log d. And that would be option 4. Number 2, the inverse of y equals 10 to the x is obtained by reflecting y equals 10 to the x in the line. Well, in order to find an inverse of an equation that is graphed, you simply reflect over the line y equals x. So that would be option 1. Number 3, the graph of y equals log base 4 of x lies entirely in quadrants. Well, the graph of a log function is the inverse of an exponential function. And if you recall, exponential functions would usually lie in quadrant 1 and 2. Again, this is exponential. Would usually look something like this. And so the inverse of that would end up being in quadrants 1 and 4, right? Remember, because we're reflecting over the line y equals x. Now just take your calculator and just simply double check. Key it into y equals. All right. Y equals alpha window number 5 log base 4 of x. There's the graph in quadrant 1 and 4. So that's option 4. Number 4, if log a equals x and log b equals y, then log square root of a times b is equal to. Okay, so we're going to take our log of square root of a times b. Remember, square root can be written as the fractional exponent 1/2. And we expand. So that 1/2, that exponent comes out in front as a multiplier. So that would be 1/2 log a plus log b. And now log a is equivalent to x, so replace log a with x. And log b is equivalent to y, so replace log b with y. So we have 1/2 times x plus y. And now distribute the 1/2, so 1/2 x plus 1/2 y, which is option 3. Next, number 5. If log base x of 3 equals 1/4, what is the value of x? All right, well, this is log form. Let's switch to exponential. Remember, log base. So our base is x, our exponent is 1/4, and our answer is 3. Now, how do we solve this? Recall from Chapter 7. We have x raised to the 1/4. We want x to the first, so we raise both sides to the reciprocal of 1/4, which is 4 over 1, or simply 4. 3 to the 4th is 81. Number 6, the equation y equals a to the x expressed in log form. This is exponential form, right? A is our base, x is our exponent, and y is our answer. So our exponent x is equal to log base a of y. Option 2. Number 7, if log 6 equals a, then log 600 is equal to. Okay, so we want to express 600 as the product of, we've got to use 6 and then I guess powers of 10, right? 600 is equivalent to 6 times 10. All right, so we'll expand this to log of 6 times 10. The log of the product is equal to log 6 plus log, I didn't mean 10, I meant 100. Sorry. Log 6 plus log 100. Log 6 is equivalent to a, so let's replace log 6 with a. And then the log of 100 is 2. Certainly if you don't recall that, then go to the calculator, simply key in log key 100. It's 2. So this is equal to a plus 2. Number 8, if the graphs of y equals log base 4 of x and y equals 3 are drawn on the same set of axes, they will intersect when x is equal to. Well, in other words, if we replace our y with 3 here, we have 3 is equal to log base 4 of x. So this is solving it algebraically, and then we'll look at it graphically. This is log form, can't do anything, so switch to exponential. So our base 4 raised to our exponent 3 is equal to x, and 4 to the 3rd is 64. So option 1. If we go to the calculator, all right, and if we key in log base 4 of x, alpha window number 5, and then y equals 3, put 3 in for y2, look at the graph, and we'll look for the point of intersection. All right, well, we can't see it here. Well, we know our x value has to go all the way up to 64. Let's just check the table. And kind of already know 64. Not a very efficient way. I guess our algebraic method is much more efficient. There it is. X value of 64, x value of 64, your y values are equivalent to 3. Number 9, which value is not in the range of the function y equals log base 5 of x? Well, again, remember our log functions are going to be in the first and fourth quadrants, and our y values are all real numbers, right? Our x values have to be greater than 0, but our y values are all real numbers. So the range is y is a set of all real numbers. Number 10, the inverse of y equals log base 4 of x is, all right, let's go through the steps. All right, switch x and y. So x is equal to log base 4 of y, and now solve for y. base 4 to exponent x is equal to y. So y equals 4 to the x, option 2. Number 11, which expression is not equivalent to log base b of 36? All right, so in other words, we have to represent 36 as, let's see, it can be represented as 6 times 6, or 9 times 4, or how about a division? 72 divided by 2. All right, so the 6 times 6, that would expand to log base b of 6 plus log base b of 6, or it can be written as 6 squared, in which it would be 2 times log base b of 6. Then 9 times 4, that would be log base b of 9 plus log base b of 4. And then 72 divided by 2 would be log base b of 72, subtract log base b of 2. All right, so choice 1, that would be 2 to the 6, but 2 to the 6 is not 36. So option 1 is the one that is not equivalent. Number 12, we want to simplify the expression e to the x times 2 e to the 3x minus 1. Okay, so the coefficient here is 1, so we're multiplying. These are the same variable bases. 1 times 2 is 2. E to the x times e to the 3x minus 1. We're adding exponents, right? So this would be e to the x plus 3x minus 1, which is simply x plus 3x is 4x. So this is e to the 4x minus 1, and with a coefficient of 2. So 2e to the 4x minus 1, which is option 4. And number 17, if log 7 equals a, what is the value of log 490 in terms of a? Let's see, 490, thinking 7 times 7 is 49, times 10 would be 490. So this would expand to log 7 plus log 7 plus log 10. Replace log 7 with a, so a plus a, and log 10 is equivalent to 1. Remember, if you don't recall, just key in. Log 10. It's 1. A plus a is 2a, so 2a plus 1. Okay, and this concludes our video for tonight. Thank you very much.